Hello, algebra students. Mr. Lawrence here, and we are going to take this, what we've been doing with graphing quadratics into quadratic inequalities. After today's video, you'll be able to say, I can graph quadratic inequalities. Now remember, when we went to graph quadratic equations, we did a couple of things, right? First of all, step one was to use the discriminant, the b squared minus 4ac part of the quadratic formula, to find out how many solutions, okay? If there were two solutions, remember we got a positive for our discriminant, we would then, step two would be to find the vertex, and then step three would be to um, use the quadratic formula to find the roots. And then, of course, we'd graph it. That would be the fourth step. But if there was 1 or 0 solutions, we found the vertex, which in the one case is easy. So we still find the vertex. And then we used a t-table to find two more points. And then, of course, the fourth step was to graph it. All right, so we're going to do the same thing, except when we do it on these, we're going to need to have some shading and possibly some broken parabolas. So let's get down to it. All right, first of all, on problem number 1 here, I'm going to use the discriminant. I'll do all my discriminants in blue. So step 1, I'm going to list A, B, and C, and Austin Blackley will tell us the easy as 1, 5, 6. All right, so we list A, B, and C, and then we go right to b squared minus 4ac, right? So we do 5 squared minus 4 times 1 times 6, and so we're going to get 25 minus 24, and that's going to equal 1. So we know we have two solutions. So now I'm going to go and find the vertex. So I'm going to do x equals the negative of b over 2a, which is going to end up being negative 2.5. And I'm going to need a t-table to help me get the y-coordinate. I know that the x-coordinate is negative 2.5, and my y-coordinate is going to be a negative 0.25, right? Okay, so there's my vertex right there. And so I'm going to go ahead and graph that, negative 2, and then 2.25, right about that. Now, by the way, A is positive, so I know it's going to open up. So I'm going to label negative 2.5 and negative 0.25. All right. Now, there are two solutions, right? That's what this means, two solutions or two roots. So I'm going to use the quadratic formula to go and find them. So I'm going to do the negative of b plus or minus the square root of 1. Remember, I've already done the b squared minus 4ac part. And that'll be over 2. All right, which will be negative 5 plus or minus 1 over 2, which means my roots will occur at negative 6 divided by 2, negative 3, 0. And the other root will be at negative 4 divided by 2, which would be negative 2, 0. And so I'm going to plot those. Right? So that'll be negative 3, 0, and negative 2, 0. And now I need my parabola. No, that's not what I thought it would be. Oh, there's what I want to do. Yeah. Oh, it's not going to do it for me. I thought it would. Okay, never mind. I can just do it this way. So my parabola is going to be solid because it says equals to. And so I'm going to go like this. Right? Okay, now, because it's an inequality, I have to use a test point for shading. And so I'm going to plug in the origin into the original equation, right? And so I'm going to plug 0 in for y greater than or equal to 0 squared plus 5 times 0 plus 6. Simplifying will tell me that 0 is greater than or equal to 6, which I know is not true, so I won't shade the test point. So my shading will be inside the parabola, inside the U. Okay? Should be pretty simple. All right, let's go down to problem number 2. I'm going to use ABC. And I'll bet you Kayla can tell you easy as 1, 0, negative 4. Okay, and so I'm going to go to my discriminant, b squared minus 4ac, and do 0 squared minus 4 times 1 times negative 4, which is going to equal positive 16. So there's going to be 2 roots. I'm going to go find my vertex. X is going to equal 0 over 2 times 1, which is just 0. In my t-table, 0 will yield an answer negative 4, so my vertex is at 0, negative 4. 2, 3, 4, right there. I know it's opening upward because A is positive, and so I'm going to put 0, negative 4 on there. Now I'm going to go find my roots. There's 2 of them, so I'm going to use the quadratic formula. So let's see here. X is going to equal a negative of b plus or minus the square root of 16 divided by 2, right? Which is going to get me plus or minus 4 divided by 2. And that will get me the root of 2, 0, and the root of negative 2, 0. So 2, 0, and negative 2, 0. Okay, and now it's equal to, so it'll be a solid parabola. And I'm just going to do my little cloning trick here and mirror image that. That way it looks exactly symmetrical. And there we go. Okay, now once again, it's an inequality, so I have to use a test point. So I'm going to plug in 0, 0. Oh, that didn't work. There we go. Okay, I'm going to plug in 0, 0 for my test point. The only time I can't do that is if the parabola passes through 0, 0. It's right here. I'll go 0 is less than or equal to 0 squared minus 4. And in this case, 0 is less than or equal to negative 4. That is not the case. 0 is not less than negative 4, so I won't shade the test point. I'll shade all this stuff out here. Hopefully this is seeming really simple. Okay, 2 more quick examples. All right, this one here. First off, going to list A, B, C. A, B, C, and Aaron Smith can tell you as easy as negative 1, 7, negative 12. Not as melodious as some of them, but it still works. Let's go looking for the discriminant. B squared minus 4AC. So B squared is 7 squared minus 4 times negative 1 times negative 12. Looks like I made a 49 minus a 48, which is going to equal 1. There's going to be 2 roots. All right, go looking for my vertex. X is going to equal negative 7 over 2 times negative 1, which is going to be 3.5. I'll go to a t-table. Negative 3 and, oh, positive 3.5 in for x, right? Just a coincidence, by the way, that I got 0.25. It's similar to the other one, but it's just coincidental. It's based on the numbers I pick. All right, so I'm going to go 1, 2, 3.5, and then up a quarter. Now I know this parabola is going to open downward because a is negative, so I'm going to put the coordinate above. All right, so let's see here. I've got to go find my roots now. So I'm going to do x equals the negative of b plus or minus the square root of 1, because I've already done the b squared minus 4ac. Whole thing is over negative 2, and so that's going to mean that negative 7 plus or minus 1 divided by negative 2. That's going to yield 2 roots. Let's see, negative 7 minus 1, negative 8 divided by negative 2 is going to be 4, 0. And then negative 7 plus 1 is negative 3 divided by negative 2. Excuse me, it's negative 6 divided by negative 2. It's going to be 3, 0. And so have a root there, 3, 0. Going to have a root there, 4, 0. Now, this is not an equals to, so it's going to be a broken parabola. Something like that. And then, let's see, is that all one thing? Nope, it's not all one thing, so I'll just draw it by hand. And it's going to go something like that, okay? Now it is an inequality, so one more time I have to use a test point. And I'm going to plug 0 in for y and 0 in for x. And I get the statement that 0 is less than negative 12. Not true. I will not shade where my test point is. I'll shade where it isn't. It's not inside the parabola. Okay, I think that's enough examples there. Of course, if I come up with a situation where there's only one root or whatever, it gets a little bit easier. All right, Mr. Lawrence signing off. Have a good night, everybody.